Greetings, boys and girls. In today's video, we are going to be adding and subtracting fractions with unlike denominators, or I could call them unlike fractions. Something to keep in mind when you get ready to add or subtract fractions that have different denominators is you first want to rewrite the fractions so that they both have a common denominator. So we'll be making equivalent fractions. Once I'm able to do that, then I'll be able to add or subtract like fractions. Okay, the fractions will have the same denominators, so we're talking about the same parts of a whole. Okay, and then the last step will be to simplify if we need to do that. You don't always have to simplify afterwards, but a lot of times you will. So make sure you check to make sure you don't need to still simplify. Let's look at our first problem. For our first problem, we're going to be adding 5/8 plus 3/10. Now, I want to make sure that my denominators are the same. I want to talk about the same parts of a whole. So I have eighths and tenths. So if I thought about all of my multiples of 8, I would have 8, 16, 24, 32, 40. Ooh, I'm going to stop there because I know with tens, I'm going to have anything that ends in a 0. So 10, 20, 30, 40. So the least common denominator that I can make both of them have is going to be a 40. So now I'm going to rewrite 5/8 as a fraction, an equivalent fraction with a denominator of 40. So 8 times what gives me 40? 8 times 5. So I'm going to multiply 5/8 times 5 over 5, which is going to equal 25/40. Okay, now I'm going to take my 3/10, and I want to make an equivalent fraction to 3/10 with a denominator of 40. So I'm thinking 10 times something is going to equal 40. Well, it was 10 times 4. So I'm going to multiply 3/10 times 4 over 4, which will equal 12/40. From here, I am now able to add my fractions with like denominators. 25/40 plus 12/40 would equal 37/40. I do know that 37 is a prime number, so therefore I do not have to simplify 37/40. Okay, 37 is, the only way I can get there is 1 times 37. 40, there's lots of ways to get to 40, but because the only number I'm going to be able to divide the numerator and denominator by is 1, 37/40 is simplified. All right, let's look at the next problem. Remember, you can always pause the video if you need to catch up. In our next problem, we're looking at 3/5 plus 1/4. I do not have the same denominators, and I need to have the same denominators. Okay, so I'm thinking of what is the smallest multiple, the least multiple that 5 and 4 will have in common, that I can change my denominator to. Okay, so the least common multiple or the least common denominator is what I'm trying to get. So I'm thinking of 5. My multiples are 5, 10, 15, 20. Oh, I'm stopping at 20 because I know that 20 is also a multiple of 4. So let's list the multiples of 4. 4, 8, 12, 16, 20. All right, so 20 is going to be our least common multiple or our least common denominator. So what I want to do is I want to multiply 3/5 by a multiple of 1 that's going to give me a denominator of 20. So 3/5 times 4 over 4 will give me a denominator of 20. Now remember I said a multiple of 1? We remember that 4/4 is the same thing as 1. Okay, so now I'm just multiplying 3 times 4, which is 12. 5 times 4 is 20. Okay, same thing with 1/4. I want to multiply it by a multiple of 1. I shouldn't say a multiple of 1. I do want to multiply it by an equivalent fraction so that I can get it to have a denominator of 20. So 4 times 5 over 5. Okay, because I know that 4 times 5 is 20. 5 times 1 is 5. So 1/4 is equivalent to 5/20. Now I can take my 12/20 and my 5/20 and add those together because I now have a common denominator. 12/20 plus 5/20 would simply equal 17/20. And another good situation, 17 is also a prime number. And so the only way I'm going to get to 17 is by multiplying 1 and 17. And 20, I can multiply 1, 2, 4, 5, 10, and 20. But they don't have any factor in common other than 1. So 17/20 is simplified and our answer. Okay. Press pause if you need some time to catch up. Otherwise, we'll look at another one. Okay, this time we have 4/7 and 1/8. I'm trying to think of a common denominator because right now I have a 7 and an 8. My denominators aren't the same, so I can't just simply say, oh, I'm going to say the answer is 5/15. I can't do that with fractions. I need to make sure I'm talking about the same size pieces. So I'm thinking of the multiples of 7. I want to get to something that it'll share in common with 8. So I have 7, 14, 21, 28, 35, 42, 49, 56. Well, I'm going to stop there because I at least know that 7 times 8 is 56. So let's try the 8s. 8, 16, 24, 32, 40, 48, 56. All right, so 56 is going to be our least common multiple. Now, to get to 56, I'm going to have to multiply 4/7 times 8 over 8 because that will give me an equivalent fraction with a denominator of 56. 4 times 8 would be 32. Okay? Likewise, with 1/8, I'm going to have to multiply that by 7 over 7 because that will give me an equivalent fraction with a denominator of 56. 1 times 7 would be 7. 8 times 7 is 56. So from here, I'll be able to add 32/56 plus 7/56. And I get 39/56. Okay. From here, I'm going to think and try to figure out if there are any factors. Okay, I don't know if 39/56 is simplified. So I'm thinking to myself, what are the greatest common factors between 39 and 56? So 39, to get to 39, I know 1 times 39. Oh, it's also 3 times 13. See, no even numbers are going to go into 39. No 5's not going to go in. 7's not going to go in. Yeah, it's just because there wouldn't be 9. Nope. 11 wouldn't work. Okay, so it just would be to 13. So it's 1, 3, 13, and 39. And then the factors of 56, I know, of course, 1, 2, and 28. Let's see, 3, I add 5 plus 6, that's 11. So 3 doesn't work. 4, oh, 4 is a factor. 4 times 14. Okay. Oh, and then 7 and 8. Okay, because 6 would not be a factor. All right, so they would not have anything in common other than 1. So 3956 is in simplest form. Okay, let's look at one more addition problem. This is actually a word problem. Tasha ate 1/3 of a pizza. Jay ate 3/8 of the same pizza. What fraction of the pizza was eaten? So I'm combining two amounts. I'm adding 1/3 plus 3/8. I first need to make sure that I'm talking about the same size pieces, so I need to get my denominators to be the same. When I think about my factors of 3 and my factors of 8, my multiples of 3 and my multiples of 8, the common multiple is going to be 24. So I am thinking 1/3 times something is going to give me a denominator of 24. So 3 times 8 would give me 24. So therefore, I'll multiply my numerator also by 8. And 1 times 8 would be 8. Okay? 3/8. To get my eighths to have a denominator of 24, I'm going to be multiplying my eighths by 3 over 3. So therefore, 8 times 3 is 24. 3 times 3 is 9. And now I'll be adding 8 24ths plus 9 24ths. When I add those together, I get 17 24ths. Notice my denominator stayed the same. And the good news is this is already simplified. I do not have to divide these by anything else. Okay? And that is because 17 is a prime number. The factors are 1 and 17. 24 has many factors, and 17 is not one of them. All right, let's look at some subtraction problems next. I'm going to do basically the same process when I get ready to subtract fractions with different denominators. I want my denominators to first be the same. So here I have 2/3 and 3/10. My denominators are a 3 and a 10. Just thinking about my multiples of 10, I have 10, 20, 30. I know that the least common multiple is going to actually be 30. So I'm thinking of 2/3, and I need that to have a denominator of 30. So 2/3 times something over something is going to give me something 30ths. Well, 3 times 10 is going to give me 30. Therefore, I'm going to multiply 2 times 10. Okay, so I can have an equivalent fraction. So 2 times 10 would be 20. Now for my 3/10, I'm going to multiply that by 3 over 3 to get an equivalent fraction with a denominator of 30. 3 times 3 is 9. 10 times 3 is 30. So now I am subtracting. Don't forget that you're subtracting and actually add again. So 20 30ths minus 9 30ths would equal 11 30ths. 11 30ths. And when we look at 11 30ths, the good news is that is also in simplest form. The numerator is 11, which is a prime number. The only way I can get to 11 is by multiplying 1 times 11. And I know for 30, I have 1, 2, 3, 5, 6, 15, 10, 15, and 30. Okay? All right, so our answer is already there. Okay, for this next one, we have 7/8 minus 1/4. Now this is really exciting. I want to have the same denominators, and I have an 8 and a 4. Well, I know that if I list my multiples of 4, I'll start with that one. I'd have 4 and then 8. So 8's a multiple of 4. So I'm going to stick with 8. Okay? So to get 7/8 to have a denominator of 8, it already has it, so I don't have to do anything different. But for 1/4, I'm simply going to take 1/4 and multiply it by 2 over 2, which would give me 2/8. Okay, now I'm going to subtract 7/8 minus 2/8. And my answer is 5/8. 5/8. Thankfully, you all will have a lot of problems like that where you really just have to change one denominator. Okay, let's look at another problem. 7/12 minus 1/6. I have a 12 and a 6. And this is very similar to our last problem where we only had to change one denominator. Because I'm looking at my 6's, and I know that 6 times 2 is 12. Okay? So I'm going to leave 7/12 as is, but 1/6 I'm going to multiply by 2 over 2 so that it will also have a denominator of 12, and the numerator will be 2. Now I'm able to subtract. 7/12 minus 2/12 equals 5/12. And boys and girls, 5/12 is simplified. It is simplified. Okay? Last problem we're going to look at is this word problem. The table shows the distance each student ran on Wednesday. How much farther did Joey run than Stevie? So Joey ran 2/3 of a mile. I said Stevie. His name is Steve. Steve ran 1/6 of a mile. So to answer this question, I need to have common denominators. Oh, and I do want to say, when it asked how much farther than, this is just like when we see how many more. This is one of those problems where we know we're subtracting. Okay, so I'm subtracting 2/3 miles minus 1/6 miles. And I want my denominators to be the same so that I can do this problem. So I have a 3 and a 6. If I skip count by 3's, I would go 3, 6. Oh, look, that's actually the multiple. So I'm going to make both fractions have a denominator of 6. I only have to change 2/3. And I will change it by multiplying 2/3 by 2 over 2. My result is 4/6. From here, I can subtract 4/6 minus, my 1/6 didn't change, and I get 3/6. Looking at my answer choices, I have 1/12, 5/12, 1/2, and 5/6. Now what you guys probably notice is that is not 3/6 is not one of my answer choices. You also may realize that 3 is half of 6. I can simplify 3/6 by dividing it by 3 over 3. And when I do that, I get 3 divided by 3 is 1, 6 divided by 3 is 2, 1/2, and look, it's answer choice C. Answer choice C. So boys and girls, I hope you enjoyed this video. We added and subtracted unlike fractions. So the fractions did not have the same denominator. This is one of those skills you want to continue to practice. IXL has some great levels on this. And practice makes perfect. Until we meet again, take care.